All right, here we go. We're going to talk about a couple different types of triangles here. Actually, let me go over here. I've got one. I'll tell you what. I'll use this one. And I'm going to rotate it around just a little bit just to make it look a little different. Okay, that's close enough. No, this is it. So I want you to see it. All right, let's pay attention now. Shh, let's not talk. Yes, I want you to draw. Okay, watch this triangle right here. And we've talked about these types of triangles, but if I told you that this side was equal to this side, what kind of triangle do we have here? It's isosceles triangle. Good. Now look, as much as I've stressed to spell isosceles right, you guys are killing this word, all right? It's not that hard. Let's go through it again. And let's concentrate. Isos, I-S-O-S, right? I-S-O-S. And then Celes. How do you do the Celes? C-E-L-E-S. Some of you guys are just murdering this word. I mean, and I go over it all the time, don't I? In fact, I thought about actually having a spelling test on some of these words. Okay, and I should, because I want you to spell these things right. It's not that hard. Spell the word right. Here we go. Let's talk about this. What? I can't remember. Let's watch. I don't have enough time to answer those questions, okay? They're just silly questions. Let's continue. Look at this. If these two sides are equal, this is the non-equal side. We call this side the base of the isosceles triangle. And we call the two equal sides the legs, all right, of the isosceles triangle. So they'll refer to that every once in a while. Now watch. If I have an isosceles triangle, here's a theorem. This is called the Isosceles Triangle Theorem. Okay, so Isosceles Triangle Theorem. It's very simple. Watch. If the two legs are equal to each other, if it's an isosceles triangle, and these two sides are equal to each other, the isosceles, that's not us, the Isosceles Triangle Theorem says this. If these two sides are equal, the angles opposite those two sides are equal to each other as well. So that means that this angle is going to equal this angle right here. And they actually give this a name too. They call these the base angles. All right, so these two angles that are across from the two equal legs are called base angles. So if you have an isosceles triangle, the base angles are going to be equal to each other. Does that make sense? So if I said that that length is 5 and this length is 5 and this was 30 degrees, what could you tell me about this angle over here? That's going to be 30 degrees. Good. And then if you wanted, you could figure out what this is, couldn't you? So if this is 30 and this is 30, that's what? That's 60. Take away from 180, it's 120. So you could figure out that as well, couldn't you? You see that? That's a lot of stuff that they could give you to do. Now watch. That's the isosceles triangle theorem. It says if you have an isosceles triangle, the base angles will be equal to each other. You with me? Now what if you had a triangle that, I'm not going to redraw all this stuff, but what if they told you that these two angles were equal to each other? They didn't tell you it was an isosceles triangle. They just said, here's a triangle with two equal angles. Guess what must be true about those opposite sides? They must be equal as well. That's the converse of the isosceles triangle theorem. The one says if the legs are equal, then the opposite angles are equal. Okay? Then the converse says if the opposite angles are equal, then guess what? The opposite sides are equal. You see the difference? All right. So there you go. Again, if I said, let's say I told you this was 30 and this was 30 and the length of this was 5. What would the length of this be right here? It would be 5 as well. Now, you really couldn't find what this base is, not right now anyway. Maybe later on with some more math, some Algebra 2 type of math, you might be able to figure that out. But right now, we're not going to figure out what the base is. All right? But later on, you probably could. But all I'm concerned about is that you find the two legs. So if they told you these two are equal, this was 5, then this over here has to be 5 as well. Make sense? Yeah, that's pretty easy. All right, here's a triangle right here. Now, just kind of looking at it, what do you think that is true about this triangle? It's more than just isosceles, it's equilateral, exactly right, okay? So this side, and this side are equal to each other, so it's equilateral. You follow me? Now let's think about this. We just said, and it's also isosceles, so Scrap, you are right. It is isosceles because two of the sides are equal, correct? Now watch, if these two sides are equal, what must be true about these two angles down here on the bottom? They got to equal as well. Now watch, let's take this a step further. Look, this side and this side are equal to each other as well, aren't they? So look at the opposite angles to these sides. That would be this one and this one. So tell me what I can do with this angle. That's equal to this one as well. You see it? So what must be true about all three angles now? All three angles are equal. So guess what? We have another theorem. Because I said that this side and this side are equal to each other, so it's an isosceles triangle this way, right? So look, this angle has one arc, so what's the angle opposite this side? This one right here. So if this has one arc, they have to be equal to each other, because if I have two equal sides, then the angles that are opposite have to be equal as well. Joel?
Didn't you say anyways that no matter when you had an equilateral, it's always going to be equal angle?
I did, but we didn't officially say that. I don't know if you remember, but I said something to the fact like, well, this is free of charge. This is something you're going to learn later. We're not officially learning it right now, but now today, on November 17th, we are officially learning it. Okay, so it's official now. Before I just kind of alluded to the fact, but now we're officially learning it. Now let's take a look at this. Look at these three angles right here. They're equal to each other, aren't they? What do all three angles add up to be? 180. So if they're equal to each other, let's call this x, let's call this x, and let's call this x. Okay? Now I can call them all x because they're all equal to each other. And what do we say if I added them all up? So what's x plus x plus x? Right, and that should equal 180, correct? So x plus x plus x is 3x. That equals 180. Divide by 3. So what's x equal to? How about 60? 18 divided by 3 is 6, okay? So it's 60. So look, this angle right here is 60 degrees. And what is this one? That's got to be 60. And what's this one? That's got to be 60 as well. So anytime you have an equilateral triangle, you're going to have an equiangular triangle. Everybody watching? Dion, you getting all this? So look, anytime all three sides are equal, what does that tell you about all three angles? They're equal to each other as well. So what are the degrees? What are the measurements of all three angles? 60 degrees. Does it matter that the triangle is real big? Or what about if it was real small like this? What could I say? If this was equilateral, what could I tell you about all three angles here? They're not just equal, but they're equal to what? 60 degrees. Even though it's a tiny little triangle, those angles are still 60 degrees. Do you agree with that? Watch. I'm going to grab this triangle. Watch this. And I'm going to put it right here. Do you see that angle? It matches up exactly with that big triangle. Would you agree? Just because the triangle's smaller, does that mean that the angles are different? No, they're exactly the same. All right, so that's kind of cool, isn't it? All right, that is. That's pretty much it. I told you it was pretty easy, didn't I? All right, just hang on. Let me give you a worksheet, then you can go. All right, let me give you a worksheet. We'll have that, and I believe that might be the last homework for the week. We're going to have a quiz on Friday, though. Remember that? Okay.